All right, I'm going to look at how to determine if a function is even, odd, or neither. So here's the rules that we have. If our function, f of x, if we find f of negative x, and it equals our original function f of x, then the function is even, and it's going to be symmetric about the y-axis. Now if we take that function and we plug in negative x and find f of negative x, and the result is negative f of x, or the opposite of our original function, then the function is odd and it's symmetric about the origin. So let's look at a couple examples and see if we can make this determination. All right, so for the first one, f of x is equal to x to the fourth minus 3x squared. And we want to determine whether it's even, odd, or neither. So the first thing we need to do is find f of negative x. So this means anywhere I find an x in my original function, I'm going to replace that with a negative x. And then the next step is we're going to simplify. So negative x to the fourth power means that we have negative x times negative x times negative x times negative x. And these two negative x's would become a positive x squared. Same thing with those. And so the result of that would be a positive x to the fourth. And then we'd have a similar thing happen with this negative x squared, and it becomes a positive x squared. So what do we find out? Well, I notice that this is the exact same as my original function. So f of negative x ends up equaling f of x. So the rule said if f of negative x equals our original function f of x, the function is even. So let's look at the symmetry of this function. So I've included the graph over here of f of x equals x to the fourth minus 3x squared. And what I notice is that this graph of this function is symmetric to the y-axis. If I was able to fold that in half right along that axis, these would match up perfectly. So because it is an even function, it means it's going to be symmetric about the y-axis. Let's take a look at this next function and determine whether it's even, odd, or neither. So again, we're going to find f of negative x, and we're going to plug in a negative x anywhere in the function that we find in x, and then we're going to simplify that. So negative x cubed is a negative x times a negative x times a negative x, which remains as a negative x cubed, and then negative x becomes a positive x. And so what I notice is that this term is the opposite of that term as far as signs go, and that term is the opposite of that term. So we end up that f of negative x is equal to negative f of x, or the opposite of our original function. So remember, if f of negative x is equal to negative f of x, that means our function is odd, and then we'll talk about the symmetry. So again, let's look at the graph of this function. So I've included this graph off to the right, and as we look at it, we see that if we were to rotate that graph around the origin, after a 180-degree rotation, it would end up lining up with itself again. So we can tell that it has that it's symmetric to the origin. And that should be apparent because we determined that it was an odd function. Now let's take a look at number 3. So again, we'll do the same test. We'll find f of negative x. So I get negative x to the third power minus a negative x plus 1. So negative x to the third power is a negative x cubed, minus a negative x becomes plus x, and then we have a plus 1. Now, as I compare this to my original function, I notice that the first term is opposite, the second term is opposite, but the plus 1 is the same in both of those. So f of negative x is not f of x, and f of negative x is not the opposite of f of x. So in this case, our function ends up being neither. Now, looking at the symmetry of the graph of this function, I noticed that it's not symmetric about the origin, and I also noticed that it is not symmetric about the y-axis. It does have some rotational symmetry, but it's not at the origin, and like I said, it doesn't have that line symmetry, and so we can see why this is neither odd nor even. Okay, for this next part, we're going to look at the graphs of the functions and see if that can help us predict whether the function is odd, even, or neither. So, looking at this first function, as I look at it, it appears as if it has some symmetry about the y-axis. So, if that is true, then this function is going to be an even function. But let's verify that with our algebra. So I'm going to find f of negative x. So as I simplify this, negative x to the fourth power becomes a positive x to the fourth power. The negative x squared becomes a positive x squared, and then we have our negative 3. So notice that these terms are the exact same as our original function. So we've determined that f of negative x is equal to f of x. Therefore, the function is even, just as we predicted. All right, let's take a look at the next one. So we have f of x is equal to the absolute value of x minus 3. Now again, as I look at this, I see that there is some symmetry, some linear symmetry, but that's at x equals 3. It's not at the y-axis. So I'm predicting that it's not going to be even. And then if I look at the origin, if I was to rotate this around the origin, it's not going to line up unless I go all the way around. I have to go all the way 360 degrees. So it's not going to have symmetry about the origin. So I'm going to predict that this is neither even nor odd. But we're going to verify that with the algebra. So I'm going to find f of negative x. That's going to equal the absolute value of negative x minus 3. And I can see that that is not equal to the original function. And it's not equal to the opposite of the original function, which, by the way, would have been negative absolute value of x minus 3. So in this case, it's neither. All right, and finally, let's look at this third function. So looking at the graph, man, it looks like if I was to rotate that around the origin, that it would line up with itself after just 180 degrees. So my prediction here is that this is going to be an odd function, but I need to verify it with the algebra. So f of negative x is equal to the cube root of negative x minus a negative x. So as I simplify that, if I take the cube root of a negative, it's going to remain negative. So I'll have a negative cube root of x, and then negative or minus a negative is going to give me a positive x. And so I see that this is opposite the signs of that, this is opposite the signs of that, and it looks as if I have that f of negative x is the opposite of our original function, which means that the function is odd.